Stefan Knust, or Knust? Knust. Stefan is an architect and the director of sustainability with Ennead Architects in New York City. He is a certified U.S. passive house consultant and has over 20 years of experience in the design and construction of complex institutional projects that serve the community and student learning. He's previously worked with New York City Audubon discussing window strikes. And he will be describing site considerations and the application of LEED Pilot Credit 55. So,
Is this still on? So I set my alarm to go off at 12:40 to remind myself to stop in time for questions within the time frame in your schedules. And I know everybody has more stuff to do today, so I really don't want to go very deep into this. And so please feel free to go. There goes my alarm. So much for getting very far. So. The title, I tried to come up with the title that was different from the expected titles from the folks that are here today, because we're covering a lot of sort of familiar territory. And I think the point I was trying to make with choosing this title, design tools for indexing, it's because in our profession, architects, and probably all of you, use tools to balance expectations and responsibilities. And this topic is one of many, many topics that falls under sustainability and resilience and wellness, which is something that's really tough to talk about with the entire sort of value chain that you described up there, even internally to a design office. Every client is different, every site is different, every project ultimately wants to be different, and every designer is bringing something different, and so bias plays a big role in this as well, intended, unintended. I read a report recently that said that 90% of our behavior and decision-making is subconscious. So there's a lot going on in conversations that are talking about performance that isn't codified in some way. So we wouldn't be here today if there was a policy already in place that was enforceable. And I'm looking for the clicker. Is it anybody's hand? Here it is. But so what would that look like? And so that's what I spend my time trying to think about for these types of questions. What does it look like? What are we aiming for? And when we're developing the narratives around our stories for our projects, I tell the teams that any line that you draw, say, or write has a consequence. And I think we all need to sort of understand our world better in terms of ecologists, because we can actually influence outcomes if we think about, some of these impacts a bit further. This conversation sort of happens within the sort of group of advocates for this topic within New York City. And ultimately, architects are really limited to what they, A, are trained to do, B, are sort of held responsible for in the public realm for health, safety, and welfare of the public. But there's so much more that our clients are interested in and that we're interested in. And this happens to be a topic we became interested in because we built a big glass box in New York City, the Hayden Planetarium, and learned this lesson in terms of what the impact can be on the local bird population, whether that was a local bird, yearly population or a migrating population, we don't know. But the design partner for that project took it to heart. He's sort of decided something had to be done about this. And so we used sort of strategies that are familiar to us, and this will be jargon within the design industry, but we used the sort of structures that are already in place that measure the performance of our buildings in terms of their durability and their economic value and cost, and also some of the environmental performance criteria. I think the energy code is the most familiar to all of us, that talks about different ways in which our buildings need to perform. But these are some of the metrics that most buildings can be described by, and this is also the sort of tool that was used, or at least the sketch that was used, to build an indexing tool around to say, look, we should be able to give our buildings a score. Everybody understands the idea of scoring. It's relative, but you can really define something that's better and that's something that's worse. And I think my question coming here today is, well, how can we take that approach that attempts to score materiality and what it, to me is phenomena ultimately? How do you score phenomena not only for yourself but for others and then other species? How do you do that? And then how do you apply that to a building? How do you apply that to its surroundings? Because in a way they're all connected. The environment, though, is also incredibly diverse, and we love that. To us, that's context, and this context often drives the way in which we sort of imagine our communities, because we no longer really live in this sort of broad landscape. We're really concentrating ourselves into urban environments where our relationship to nature is becoming disconnected, and yet we're also wanting more of it and bringing more of nature into our cities. And the combination of the efficiency that glass construction brings and a greater appreciation for the value of parks to us also means that those habitats are in greater risk. So these are the sort of questions at 3 different scales that I think we need to think about when we're developing new land, or even sort of reimagining existing environments. And you've seen this slide before, and one thing that's missing here is a dashed line around Canada that reflects a new standard that they've developed, which embodies sort of best practices, surface one only, as a prescriptive strategy. This is the CSA group, which is somewhat similar to the ASTM group here in the United States, that talks about how do you create a sort of a measuring system for materials. They are taking the next aggressive step, I think. But most of these have emerged from a local setting, just like this one. These are the questions that go through my mind. I'm not going to go through them all, but these are questions that I'm constantly being asked and that I would like to be able to answer, especially as we're speaking with more policy makers, with design teams, with campuses, some of whom we work for, in designing new facilities that want to sort of take this sensitivity into account in terms of the design. Or campuses where they have buildings by others and they'd like to sort of understand what have we learned along the way and what might they consider in sort of coming up with a strategy. And then also, as we reimagine what the next edition of LEED could look like, can we go beyond the building and talk more about site factors and other things that ultimately provide for a better management of resources? Because if you're doing it well, if you're taking all of these things into account at the beginning, this should not be a cost additive process. So these are just some views of different ways in which sites have been sort of prioritized. And what's curious about this one, for example, this is Manhattan, and what you'll notice is that there's a priority given to certain parts of Manhattan based upon experience that Audubon has documented. And I know that, Susan, you were the author of at least one of those studies that sort of focused in on Midtown, and I've been curious, though, how the surrounding of Central Park does not seem to be considered a hazard. It doesn't seem to have a high level of, it should be, right? Because it's directly adjacent to the habitat. So again, there are a lot of questions that come up in terms of what's really going on. This is an interesting image that reveals sort of migratory patterns, but it's also misleading because it suggests that collisions are happening equally, in this vertical axis, but it's not. Most of the collisions are really in the reddest bar of all at the bottom, in the tree zone, and yet the LEED standard right now is sort of looking at the entire building, even though it breaks that into 2 different types of zones, Zone 1 and Zone 2. LEED is really trying to address the entire building, and I'm wondering personally whether that's something that can be correlated with the data that we know in terms of where the impacts are occurring. This is a really silly diagram to kind of translate, let's say, what the experience of a scored material, and consider this all as glazing material. This is the type of element that is used to create either transparent wall surfaces or opaque wall surfaces. And then in terms of creating signals, the one on the far left, it has none. That's a clear piece of glass. And then all the way to the right, that could be a brick wall or that could be some other sort of a panel. And there are sort of different gradations there of patterns that have been discussed earlier, all of which have a sort of a tunnel index that's currently the only source of that type of an indexing effort. That information, along with anecdotal information, is then used to create guidelines, which then ultimately feed into policy suggestions. And this is my attempt to sort of look at, to me, the most interesting ones and the ones that are evolving and coming up next, and what makes them different from one another. Toronto has a wonderful history in sort of introducing this as a requirement, but they also approach it from a prescriptive standpoint, and they don't care about Zone 2. So they've, used a tool to balance this issue in sort of introducing something that was very approachable and implementable and also universally applicable. In other words, they said, all of you have to comply with this. And at that point, it's essentially code. And I think that's the direction we're headed. Sorry, am I going in the same direction? This is a series of images that I created to kind of illustrate, and I'm going to walk over to the screen. I'm on an ASTM committee trying to sort of create a standard for grading glass from a third-party source so that designers and building owners can say, look, we're trying to aim for some sort of a goal. We know that numbers are involved. We need this particular number. And in this case, we're talking about a material threat factor, and that would represent, how many times a bird aims away from it in a given condition. I've illustrated and planned three different types of tunnel scenarios, and right now this is the only tunnel that's used in a binary testing protocol where you have a clear piece of glass and a patterned piece of glass, and you let 100 birds fly through here. They're protected by nets, and they're released again. But you sort of take a note of how many birds avoid the pattern. There are more complicated tunnels being developed, and they begin to introduce what has been highlighted today as a key factor, which is reflection. And as you begin to introduce reflection, background images, I've sort of had to deconstruct this for myself as a series of images that are all stacked together. And now if you add in the component of movement, then it gets super complex. As a human being, I find this environment really attractive, but it's also incredibly difficult to navigate, especially if you're a bird. And I don't know how to score this type of thing, but this is what we're attempting to do right now, just in that particular methodology. Blow it up, and just to illustrate what might be perceived by bird. And then how can that be applied? And then how can we take that sort of approach and apply it to other patterns? You don't have to see this. This is just a quick example of a project, Ambassador, where we tried. It's also a science building, and we tried to. It's in Arboretum, and we really tried to take into account not only the likelihood of bird collisions, but also the human experience. And again, this gets back to that question of balance. This is something that was sort of carefully thought of as a building that's sort of part of the landscape. And we took the sort of pattern language of the landscape and wanted to sort of use those strategies, biophilic strategies, I guess is what it's sort of called today, to create an environment that was attractive from the outside and from the inside, and also to address some of the phenomena that occurs when you have darker surfaces behind us, lighted glass. Now we're talking about day-night differences. But we used a double frit approach where we had an inner frit layer, an outer frit layer, and two different tones, gray and black, and actually white, so a triple tone frit approach, just in order to kind of hit all the different lighting conditions that we might expect in the course of the year. And then in one zone of the building, the lower zone of all, we did use this UV product, which was new at the time. This is the Mikado product by Ornilux. All of these are applied on surface 2, and one's in surface 3, just because of the number of layers of frits in this case. And we used it for what we felt was the appropriate percentage of glass on the building. Now, this is one of the biggest factors that a designer can begin to sort of leverage against, let's say, a higher performing glass, a custom order of glass. Is that if you use the glass for its greatest impact, greatest effect, and don't use it everywhere else, because, by the way, it's a huge heat loser if you're thinking about carbon. And then you can really get some really, I would say, cost-neutral solutions in terms of multiple layers of performance. This is the lead sort of tool, which does all the geometric analysis of the structure, and then you input the material threat factor for anything that's glass, and then depending upon the zone, you get a building threat factor score, and you're aiming for something that's under 15 in this case. We've taken that, and because it was really difficult actually to bring an Excel spreadsheet to our designers when it really mattered, that's just not the way they like to design. We decided to build something sort of underneath their trace paper, so to speak, by using what are called these algorithmic grasshopper scripts to analyze as they go. And so we simply document just a few characteristics about our models. This happens to be a building in the Midwest, on campus. If you break down the rules, this is really happening in the background, and as the designer is working, there are a number of different types of things we can report out. In this bird collision deterrence rating for the building. And then these are also introduced with sliders. And so once they're aware of the fact that they're actually over the stated goal, once they move their sliders around, and this is now when they're manipulating some of the characteristics that hopefully do make it all the way into the specifications and into the value chain, then at least according to this strategy, the building is hoped to perform better than a baseline. And we just know that there are so many bits of information that actually go into this, into the collision issue, that we can't address them all. And so we're looking for easy ways to integrate information, sometimes even anecdotal information. But until the point that there's a code that can be enforced, we have to rely upon the expertise in this room and the partnerships with our teams to make decisions about how to balance these projects that are out there.